In the video called Discovering the Derivative of 1 over x by considering a special rectangle, we in fact discovered that the derivative of 1 over x is minus 1 over x squared. Hopefully you saw that in detail and you understood how that special rectangle showed us the relationship between the change in 1 over x caused by a change in x and the change in x itself, and that led to this relationship. It should have made a lot of sense, I hope it did, but you still might look at this and say, okay, but I would like to look at that picture and really see why is it 1 over x squared? Exactly how did that come about? So that's what I'm going to try to do in this video, part 2 here, to show you a little more about how you would get the feel for why it's 1 over x squared coming directly off that picture. So I'm going to review really quickly what we did in that last video. I'm going to go through it really fast. If you need more details, please go back and see the video itself. What we did was we capitalized on the relationship between 1 over x and x, which is that they multiply together to always be 1. And that shows us for sure that when x goes up, 1 over x goes down. When x goes down, 1 over x goes up. So we know that the rate of change of 1 over x with respect to x has to be negative, but we want to see exactly how much 1 over x has to go down when x goes up, for instance. And we see that by thinking of this as the area of a rectangle. This is one side, this is the height. The area has to be 1, like this. And we're going to see from this picture that when x goes up by a little bit, 1 of x is going to have to go down by exactly the right amount to preserve the area as 1. So we grew x by a fixed amount, and that's going to create more area out here, which means 1 over x has to shrink in just the right way so that the area vacated up here equals the area created. The area vacated plus the area created have to turn out to be 0 because the whole area has to turn out to be 1. That is, the delta of 1 over x, the change in 1 over x, has to be just right to make the area on top be the negative of the area on the right. And let's see exactly what these are. The area vacated, that's the height here, delta 1 over x times x. On this side, the green, the height is 1 over x, the width is delta x, so we get this. This is the key relationship. We'll subtract this from both sides, and we get this. I'm going to get rid of the other stuff just because that's the key relationship. The change in 1 over x times the full amount of x is equal to the negative of the change in delta x, the change in x itself times the full amount of 1 over x. That's the key relationship, and the rest was just some simple algebra. What we always do when we're trying to find the instantaneous rate of change, we find the change itself first. Here it is. We got to divide both sides by x to get the change by itself. That gives us the x squared. Now we want the rate of change. Dividing by delta x gives us the average rate of change, and then taking the limit as delta x goes to 0. That's how we found out the derivative was equal to 1 over x squared. So again, it makes perfect sense because this picture makes sense. The area vacated has to be the area created, and that's exactly what this relationship says. But I want to see if we can look at this a little better and see exactly why did it come out to be 1 over x squared minus 1 over x squared. And to do that, we're going to go back here. So let me get rid of these two things. We don't need them. I want to rewrite this. 1 over x squared is, of course, 1 over x times 1 over x. I want to write it like that. And the reason is because these two 1 over x's got here for different reasons. And they both play an important role in the size of the change of 1 over x. That's what we're going to look at. Let's remind ourselves where they came from. This 1 over x came from here, and that in turn came from there. It was the height of the rectangle representing the area created. On the other hand, this 1 over x got here because the x on the bottom was this x over here, which was the width of the area vacated. So they got there for different reasons. And what we want to see is, how can we see that we need both those things? The size of the change in 1 over x is related to two factors of 1 over x. That's what we're going to show. And it'll be easier to see that if we make a more extreme rectangle. I'm going to make first x bigger so the rectangle is longer and therefore lower. So let's look at that. Longer, lower, same delta x. So I want to see how we know that a big delta x, a big x, which is the same as saying a small 1 over x. How we know a small 1 over x is going to lead us twice to making the change in 1 over x small. So because 1 over x is small, this area, the green area, is less than it was before. So the area created is small, so the area vacated is small. So that's one reason why the change in 1 over x is going to be small. The area that you have to vacate doesn't have to be very much. That's this 1 over x. And the second reason that delta 1 over x has to be small is because x is big because 1 over x is small. X is big, and therefore it's doing most of the work to create the vacated area. Delta of 1 over x, the change in 1 over x, doesn't have to be very big at all. So delta of 1 over x is small because of two factors of 1 over x. One, because the small 1 over x makes the area created small, so it means the area vacated has to be small. And the second one, the small 1 over x, means the change in 1 over x's partner, x, is so big it creates most of the vacated area, so delta of 1 over x can be very small. And let's see that again, not in the case of a big X, but in the case of a small x. So let's make a rectangle like that. And so what happens this time? Again, I want to see that the change in 1 over x, which clearly is bigger this time, is bigger twice because of 1 over x. Once, because x is small now, 1 over x is big. So the area created is big. So the area vacated is going to have to be just as big. That means delta 1 over x is going to have to be kind of big. And not only that, because 1 over x is big, x itself is small. So it's not doing its work, right? It's hardly doing anything. So delta of 1 over x has to be bigger to make up for that. Again, two factors of 1 over x. One of them makes the created area, two factors of 1 over x being big. One of them makes the created area big, which makes the vacated area big. And the other one makes x itself small, meaning x is not doing much of the work, so the change in 1 over x has to do more of the work. Two factors of 1 over x, that's why we get a 1 over x squared. Hope that helps.